Yeah, so now it's time on the main stage for a panel discussion on next practice in material innovation. Design is inextricably, that's a word I'll never be able to do, tied to materials and how they're extracted, used, reused or not, decomposed or not. There are thousands of material innovations happening around us. And the panel with us this evening brings together some pioneers at the cutting edge of how we design non-toxic biomaterials that can break down naturally and regrow. So to lead this conversation, please welcome to the stage Alice Fisher, the design editor of The Guardian, who have kindly are our festival media partner today. So over to you, Alice.
Well, so this panel is about material matters, and I was thinking when I was listening to Katie Tregeddon earlier, reading from her book about people who are prepared to look at what is broken and try and think about ways to fix it. And I think this panel is a group of people who are interested in doing that. All of them work in different ways with materials and look at the way that they are produced, how they can be reused, and really try to rethink what materials we use in manufacturing. They are actually going to introduce themselves because I think they can do a far better job than I can of explaining the real kind of fascinating detail of the work that they're involved in. But I would just like to say Shruti Grover, who was going to be here from Project Pattern, unfortunately is at home with a sick child, so hope you're feeling better soon, little Shruti. And we have Sophie Vaud with us from Colorifix, who is the head of microbial engineering, just to kind of make those quick admin changes there. But so, first off, let's go in order. Edward, would you like to tell us about the plant-based paints that you produce and what made you start looking down a new way of putting paints together?
Thank you. Yes, well, I'd love to. I make house paints, emulsion and eggshell paints that we're all familiar with. And they're made in much the way that mainstream paints are made, except that we have sidestepped the petrochemical food chain. And I'm not a chemist. My eldest daughter is and has explained some rudiments to me. And effectively, when you write chemical formulas, you make no subjective judgment. You're simply recording fact. And she told me that the fundaments of paint are polymer chains, and polymer chains require linked carbon molecules. And that's when the penny dropped for me, is that, of course, carbon is really one of the most omnipresent molecules in our existence, in ourselves, in our surroundings. And so there is no very good reason why we should only use what I call fossil carbon, because plants are producing it literally every year, and in the process they're providing us with oxygen. So they're a far more sensible source for carbon. So we take waste straw and waste wheat as our carbon feed source and effectively build a polymer chain by reacting the plant sugars. There are other aspects, of course, to making paint, but actually we've been making paint for 30,000 years, so there's no reason to think that how we've done it for the last 50 or so years is necessarily better than the rest of the years we've been doing it.
Thank you very much. And Adam and Rosalie. Adam and Rosalie are from Smiles Plastic. Which is, let me just say the first thing, it's a company specializing in closed-loop recycling and materials design, if you'd like to explain more.
So we're a material and emission-driven business based in South Wales. We work exclusively with waste materials to produce decorative surface materials that can be used in the built environment, a little bit like some of the small samples at the front of the stage.
Strategically placed for you all to interact with after the discussion today.
If you want to. I think the reason that we do it, we're very much a mission-driven business with And that's driven all the decisions surrounding the choices that we've made, whether it's to do with manufacturing technology or material selection processes. And on top of that, we pride ourselves on kind of focusing on people within the organisation and how our products impact people and society. So there's this very strong message in the materials that we make. We want people to really treasure raw materials and waste materials as an option for replacing synthetic, non-renewable or renewable products which are from virgin sources.
And Sophie, Colorifix is a company founded by synthetic biologists who first met looking at the impact of heavy metals from the dyeing industry, I believe. And instead of monitoring, they decided to try and fix it. Could you explain a little more about what the company does?
Yeah, absolutely. So we are loosely defined as a tech company, but we are actually working very much at the interaction between biology, chemistry, and material science. And our mission roots in the observation back in China and in Southeast Asia by both our founders that arsenic, that's the metal they were looking at evaluating the presence in water, in fresh water, was actually not the only pollutant that we should be concerned about. The textile industry, and more importantly, the dyeing process within the textile industry is immensely polluting. And every year, we have huge amounts of pollutants that are released in fresh waters and are accountable for up to 20% of the pollution of water globally. So that's something that is, you would think, not so much of our concern in Europe, but it actually affects the whole planet. And there's a saying that goes by, in China, you know the color in fashion this year by looking at the color of the river this year. And to have seen pictures, it's actually true. So this is the reason why we have, our company is looking at reducing and even eliminating the use of harsh chemicals in the dyeing industry and reducing the use of water, energy, as well as making waste a clean process or cleaner process than it currently is.
Amazing. And could you explain a little more about the, it's taking dyes from nature and using microorganisms.
Yeah.
Is that right? Is that right?
Yeah.
Is that too simplistic?
That's what it is in a nutshell. So we are using biology to create sustainable dyes for the textile industry. So how we do that is that we look at nature, and nature is great at diversity, but not so great at scaling. And so that's how we get inspired by nature. And instead of extracting natural pigments from nature, we actually look at the genetic instruction in a given organism of which we want to recreate the pigment. For example, if I want to recreate the blue pigment of a parrot wing, I'm not going to go in the very heart of the rainforest and extract the pigment from the wing of this parrot. What I'm going to do is maybe a little bit underwhelming, but go online, check on databases, because now we are blessed by the era of data and sequencing, and have access to the genetic instruction that is responsible to make this pigment in the parrot. And then it's just about reprogramming microorganisms that can grow at scale and be brewed, just like some people brew beer. We actually brew colors in our proprietary hardware to make liters of dyeing liquor that is readily used in the dyeing industry on existing equipment. So we bring biology inside dye houses.
And so going back to you, Edward, if that's okay. So you both make colour, but in such a fascinatingly different way. How do you feel listening to what Colorifix do? Are you interested in that side of making colours?
Yeah, yes, of course. But dyes are not useful for colouring paint.
Yeah.
You need pigments for that. And there are all sorts of issues beyond the source of the dye, for instance, fixing the dye and all of that. But that's not our area. Our area is pigmenting paint. And actually, you'll hear a lot of paint companies talking about their product being pigment rich. They don't actually mean pigment as I mean pigment. So I mean pigment in the artist sense of the word, something that you take and grind to a fine powder and then bind in oil in the old days, but we bind it in water now. And we use particle pigment because the choice would be, the other choice, the mainstream choice, would be actually to use dye, I suppose you could say, but synthetic colorants. And they are dyes in the sense that they are created synthetically and then used to dye chalk. So they become a powder, to all intents and purposes, a pigment mimic, if you like. The reason that we don't use them is that a lot of the chemistry is azo dyes, which some of them at the extreme end have quite significant health concerns around them. But there are plenty of pigments that we wouldn't use either, because some of them, particularly used in the past, were based on heavy metals. And of course we all understand that lead in our paint, for instance, is not something we would want. So our standpoint is that 12 traditional pigments that artists have been using for literally millennia are easily all you need to paint the walls of houses. So we don't really need to explore any further than that. What we think is the biggest problem about paint is that it is fundamentally polluting. It's polluting at the manufacturing stage because of the supply chain and all the stages of the petrochemical supply chain, both emitting and creating waste. But we feel that the decomposition, which I think was mentioned earlier, is something that it's incumbent on all of us to recognize. And that while we're perhaps in a way of thinking that things should last forever, that they shouldn't decompose, it's actually really important that they do decompose, and how they decompose really matters. So by using only plant material, we genuinely believe that when our paints break down, they will be recognized by microbes already in the soil or the water or the air and can be effectively reintegrated. So there are downsides, of course. We use extractive industries to get the minerals we need, the pigments, but it is all in a circle fundamentally where it comes from the earth and returns to the earth. The reason we don't need to use the petrochemical food chain is simply that difference between fossil carbon and what I call everyday carbon. And none of us are choosing to use fossil carbon. We just don't probably know enough about it and haven't really thought whether it could be the only source or feedstock that we need to make plastics. And probably at this stage it is, because that's how so many plastics have been developed. We're what would be called LFP, I think, a liquid form plastic. But effectively, you're making polymer chains. And we work with a German company, and their scientific breakthrough, if you like, was to work out how to form a double bond on their carbon molecules so that they could chain them together into these polymer chains, but also have one spare to link to the other characteristics that make paint. So we literally cannot mimic everything that modern paint makers do, because they don't limit themselves to those sort of criteria. So they're using forever chemicals. They're contributing, as we were hearing, enormous amounts of microplastics to the oceans, bigger and bigger amounts as more and more research is done, funnily enough. And these are microplastics that are arriving in that state because they're being broken down. But that is the state they get to. There's no further state where they're reintegrated. They then work their way back up the food chain through the organisms that ingest them and they're now coming into the human food chain, we know, and they're being found in fetal examinations and all sorts. This ain't good. This ain't good.
But there are things we can do with waste streams, aren't there? Rosalie, would you like to talk through the process you have of finding the material, the recycling material that you use?
Yeah, absolutely. So we work exclusively with 100% recycled plastics. I mean, Adam is really king of the sort of supply chain. We're looking for all sorts of things in waste, different profiles of plastics, different plastic types, different colours and textures, and all of that sort of comes into play when we're sourcing materials, including making sure that they're non-toxic as well and safe for us to process and send on to our customers. We tend to work with materials that have an interesting story to them, and that's sort of woven into the panels that we manufacture. So we have a yogurt pot product, and it's made from recycled yogurt pots. It's got bits of foil, silver foil from the lids, actually in the panel itself, so you can sort of understand its story. We are really proud to have a new material called Heron that's made from post-consumer refrigerator linings as well. And so, yeah, we tend to choose those materials that do have an interesting narrative. And that can really engage our fantastic audiences.
Well, I mean, one thing we were talking about when we had a brief chat before we came to do the talk was about looking at things like local manufacturing and how you could use kind of local waste sources to make a plastic, which I think particularly if you're talking about you know, where the material comes from and what it is as being something that's important, sending the local community's waste into something that is productive and useful to that local community is quite a nice kind of avenue to pursue.
Yeah, I mean, there are so many levels that we need to think about. That there are more constraints working exclusively with waste materials, yeah, as opposed to virgin. And as we look to scale our business internationally, so we're already shipping out a lot of our material abroad. We're very conscious about that impact, and so very interested in this idea of local production based on where the raw materials are and also where our customer base is as well. So looking at scaling and having multiple sort of factories around the world based on where the demand is. But from a kind of waste perspective, there are so many additional constraints thinking about scalability of those supply chains, and and that's Adam. So I don't know whether Adam you want to expand on that.
I think probably the only thing maybe to expand is, although there's a kind of a very obvious product that we have been making, which are these materials, behind the scenes, what we've been doing for the last decade plus is actually trying to really come up with a really, and probably one of the reasons it's taken so long is because we spent a long time on it, is to put together the tool pack, in actual fact, to be able to recreate the quality and be able to deliver this type of system locally. So we have a really a mission to create, to make local making a global proposition with waste streams. So using the kind of the knowledge and the systems and processes and the hardware that we've invented over the years to manufacture high quality, high value products from waste materials rather than downgrading the material, and using incredibly low energy, probably 40% less than any other plastics recycling process, and probably if you compared us to another type of decorative surface material, a minimum of 50% less than something like Corian, as an example, which may be used instead of our materials. The idea really of the business is to put that tool pack together and then to disseminate it by linking up with local partnerships, creating a network of ecosystems that enable recovery of material through the processes that we've developed into valuable products for local communities. And that's very much at the core of what we've been building. It's not something that you can see on the surface of what we do because there's the day-to-day and you know, we're essentially in advanced stages of concept. So we're demonstrating in real-term scenario that a business model can exist. It does have legs. It can evolve and turn into something real and meaningful. And yeah, so that's the vision and where we're coming from with everything.
Now, one of the main themes of this festival is collaboration. So, Sophie, could I ask you first, how does collaboration work for Colorifix? Is it an important part of your process?
Yeah, I would say it's even at the heart of our process because we are trying to support the evolution of a huge industry, which is the textile industry, that is steep in history. So we have to work hand in hand with our customers, which are the dye houses. We need to learn their practices and to adjust our process, and they also need to understand what we try to do, because it's not small work to try to bring biology in an environment where biology is not necessarily understood. There are different risks and different opportunities. So we are very much involving from the beginning of our process, of implementation of our process, our customers, and they are actually very responsive and very helpful in the process as well.
And how about you, Edward? Is there collaboration in your business?
Well, I can't honestly say that 95% of paint makers welcome my existence. No. But we collaborate with a company in Germany, in Brunswick. And what's very interesting is that their paints, they're called Auro, A-U-R-O. Their paints have been available in this country for 20 years before we approached them. And they had sold a few buckets. Since we have taken the pigments and mixed them to what I would call an English aesthetic, we're selling lots of buckets. And so sometimes there can be some very simple things, often design-led, I would argue, that unlock the potency, the power of, and I guess you guys are showing it too, that we do very often have to feed the eye. And paint is an area where everybody in this room has bought some paint or employed a painter or done some painting. But I challenge any of you to tell me more about paint than I know. And I suspect, you know, probably not very much, because it's an industry that is deliberately doing that to us. So think of how many products you can buy which have no ingredients list on. Well, paint doesn't. And paint has a lot of extremely interesting ingredients. And there's lots of reasons why we might want to know what they are. But there is no legislative requirement for that. And so we do it voluntarily because we think that going back to your point about collaboration, is that we are in collaboration with you, the user of the paint, whose end is not really to think, oh, I've bought a tin of paint, aren't I clever? It's to think, this is how I want my home to be. And so we're not going to tell you why what governs that thought process. I mean, it might be an old English sheepdog walking into the room, but I rather doubt it. But that's the sort of level at which paint is kind of communicated to us. It's rubbish, you know. And so if I've got an old building, for instance, I want to know what the paint does at the level of a building product, microporosity. If I've got asthma, I want to know if it's off-gassing. If I have advanced aesthetics, I want to know if it's beautiful colors. If I'm ecologically aware, I want to know whether it's emitting carbon in its processing and its breaking down and what have you. All of these things could be voluntarily given to the consumer. And in many areas, other areas now, you are beginning to see that. So if you buy some oat milk, for instance, you're told that I think it has a carbon footprint of 6 kilos per litre or something. And incidentally, we've done our own carbon footprint on our paint, and it's less than double that for a tin of paint. This is just oat milk. So it just shows what can be done. But of course, the reason we don't want to talk about it is that 95% of paint is made in what I would call the wrong way. So the collaboration that needs to take place is with us, presenting a solution, if you like, and everybody else understanding that there is actually a problem that does require a solution. But with no laws against greenwashing, with no requirement for transparency, it's hard work. It is.
And what about Smiles Plastic? What collaboration has helped you with your business?
I suppose we've got quite a complex ecosystem, I think, at Smile Plastics. We're needing to collaborate across the board to make things happen, from working closely with our raw materials suppliers. But I think some interesting elements for us. I mean, we're constantly collaborating, with our customers. Our customers come to us with all sorts of different needs. Might be aesthetic led needs. It might be, us recycling some of their own waste, working really, really closely with them to fulfill their requirements on whatever level it is, technical or aesthetic. And I suppose we're really, really inspired by, our amazing set of clients and what they end up using our materials for. But it's a kind of onward discussion, and once the materials leave our house, we still feel fairly protective over them, and we love to have the material back. So I can't remember whether we've already spoken about it, but the recyclability of our materials is really paramount to us. So all of our materials are 100% recyclable. You can recycle them through sort of local recycling networks, but we love to have the material back at the end of its life as well, so that we can reimagine it into something new. So working closely with our clients so that we can take it back at the end of its life. And then on, Adam mentioned us sort of scaling through partnerships internationally. We have great impact over here in the UK, and it is building, but there's only so much that we can do. And if we're going to make, huge changes on a sort of international scale, then it's all about us partnering really closely with other organisations who really share our vision and our mission for the future, and who can partner with us on the manufacturing side of things, and on the sales and marketing side of things as well. So yeah, collaboration is completely interwoven into everything that we do at Smile Plastics.
I think adding on to that a little bit, we kind of say we're a triple bottom line company. So people, planet, profit. But if in terms of hierarchy, because we have a very strong environmental mission, it sort of starts with the planet and people and profit. So how do people and profit benefit from the work that we can do? People and the planet profit, and it starts with the planet. So we came from trying to create an environmental solution for a problem. How can that influence people, and how can that profit? So in a way, our biggest collaborator is the planet, and we're trying to mimic industrial ecosystems to fit with natural ecosystems, albeit these are fossil fuels, being minerals and organic matter mined from the earth that have been buried for thousands and millions of years. But we do see ourselves as a kind of a partner in this other side as well, which is a bit more sort of philosophical, essentially. So the planet is a big collaborator for us.
Yeah, because the natural ecosystems are cyclical, and they've always been cyclical. And whereas the man-made world, for whatever reason, we haven't taken inspiration yet from you know, the natural environments, and you know, we've had these very linear systems of, you know, overproduction and use, and you know, and waste has just been piling up all over the place and piling up in the wrong places. And I think we can take a lot of inspiration from the natural ecosystems around us.
Now, I'm really aware of the time, so I do want to see if we have questions.
We do. Our good friend Anonymous has been very active. So a couple of specific questions. Sophie, are the natural dyes you use able to be created with cruelty-free methods and void of animal products? And then while we're on specifics as well, there was a question for Edward. Does your paint breathe and work like with lime plaster, which is great for making a house breathe as much as people? And then I'll just do a quick couple of other questions. Anonymous has heard many people express concern over the recyclability of recycled panels. What is put in place to recapture plastics so that they will forever be able to be a raw material? And there's a linked question for, is there a clever way for your type of plastic to be recyclable at the end? Or is your way of reusing plastic waste more of a downcycling process?
So, Sophie, should we go to you first with the question about animal cruelty, which I know is something really important to Colorifix?
Absolutely. We spend a lot of time thinking about designing our products and the recipe that we use to cultivate our microorganism. And that means that the media recipe, the ingredients that we use at scale are very important, and we choose them with care, and we want them to be certified. One of the elements of this selection is actually that it doesn't contain any animal-derived elements to that. We go even further. We always want to have, at the end of the product process, the production process, you always want to have the same color on fabrics, and if you work with fashion designers, then a blue is very different. Even if for most of us, you would not see the difference, for them you would see the difference. So we have to be very careful at producing the same shade on fabrics, and that goes by standardizing our process and having a standardized way of selecting our suppliers. So alongside this certification, or this validation that there is no animal-derived product in our process, then we also want to have the best quality to sustain our product standardization and deliver the same product with the same quality time and time again in different geographies, because we operate globally. So that's part of our effort in making the supply chain as sustainable and as high quality as possible.
And so, Edward, lime plaster.
Lime plaster, yes. Well, any plaster, actually. I mean, it's crucial that paint is breathable. It's measured usually in something called the SD value. And actually, that, if nothing else, that ought to be a mandatory piece of information on a tin of paint, because it actually genuinely tells you whether that paint is fit for a certain purpose or not. So yes, because we use plant binders, we have an SD value of 0.01. You can get a better, I mean, and mainstream acrylic paints would be, you know, up to 1. You only get better with lime wash itself, or perhaps clay paint. We have this discussion a great deal with our customers. Very often they've been told, by a builder or by an architect or by a conservation officer that they've got lime plaster and therefore they require breathable paint. And so we talk them through the possibilities, and usually, let's be honest, they're living in their house with other people and don't really want paint brushing off on their clothes. So they tend to go for paints that have a little bit more structure. So our emulsion is a resin dispersion paint, so because of that, it has enough strength to withstand a lot of family usage. So yeah, basically our entirely everyday paint is suitable for even these more perhaps esoteric needs, but actually, when you see kids dying because their houses are moldy, and you see the rooms that they've been living in, and you see that black mold, that is happening because water vapor, moisture, is hitting the wall, and it can't go any further because there's no moisture vapor permeability in most cheap paint. And so there it sits, providing the ideal growing conditions for mold spores. So actually, everybody should be really interested about breathability. Even gypsum plaster has some breathability, but if you put a layer of plastic paint over it, it don't. Yeah?
Yeah.
So literally, we talk to people who've been forced to leave their houses because they've made them ill, and I know I'm looking on the news at houses that are clearly substandard in many ways, but I never hear it talked about that actually perhaps inappropriate choice of materials had something to do with this as well.
Yeah. And the question for you, which I'm really going to stumble over.
Double barrel one.
Yeah.
It's about recyclability.
I think, so in terms of recyclability, the nature of the way that we manufacture, which is a kind of a static moulding process, and the approach that we have to making pattern, which originates from the raw material itself, means that we can remove at least one manufacturing process out, which is normally required for recycling, which is an incredibly high temperature process to homogenize material to make it fit for rapid automation. Rapid automation requires material to flow through very tight pipe work around factories and blow into, and then it normally goes into a machine that needs incredibly high temperature to squirt it into a very unusual shape quite effectively. But both of those processes are incredibly high temperature. The way that we manufacture and our approach is to kind of really celebrate the origin of the raw material, to get people to see some of the little gems of narrative within the material, partly because we want to get people to engage in a slightly different way with materials. But another really important reason for it, and one of the things that we're very proud about, is it actually means that we can use almost incredibly low levels of temperature, if any at all, to come up with the various stages of the manufacturing. So we don't need heat to make material to flow because we're trying to encapsulate the idea of the material in the pattern. And that means that we can operate at much lower temperatures. We can remove lots and lots of high temperature processing, which is required sometimes to homogenize materials to make uniformity. So one of the advantages of that for recyclability is that the thing that normally degrades plastics is heat and it's high temperature. So if you can remove that out, you're removing one of the main catalysts for degrading the polymer chain. And so by doing that, we are using some heat, but we're nudging the material. We're not melting it into a very runny liquid and then squirting it around pipes into molds, and that means that the polymer chain stays a lot stronger as a result. So we're not degrading it. It means it can be recycled a lot more by other people, but primarily we want it back, because we spend a lot of time sourcing it. So we have a regular take-up of our buyback scheme, and we have some customers where we'll be cutting shapes for, where we'll actually pay for the offcuts of material before it leaves the factory. So if you compared it to maybe going to a furniture company and paying for some plyboard or MDF to be cut up, there's a lot of waste that exists as a result of cutting up that sheet of plyboard. So with the way that we operate for some projects, not just a one-off normally, but for like an ongoing business relationship, we will pay for all of that scrap and we'll put a value to that waste before the customer even is aware. And I think part of it is it's not something that we've been asked to do. We fundamentally think that it's important for people to realise the value of raw material and what can be possible. And because we're a recovery business, we want people to share the profit and share the rewards. So we will pay for that. And in some cases, like I said, before it even leaves the factory, if there is any waste, we'll let people know there's 10 kilos of waste. We're going to give you this much money towards whatever it was that you doing with us, which is a really unusual way and a slightly different way of like valuing the way that you do things. I think in terms of on recycling, coming back to us, because we don't use huge amounts of energy in the actual manufacturing process, and it's in the original situation, it does mean that we can recover the material and put it back into product. Probably not forever and ever and ever, like a million times, but certainly many, many recovery processes. A lot of the material comes from single-life plastics. So, you know, one of the reasons single-life plastics are called single-life is because they're kind of designed for very short periods of time for use. So we hope that our materials last for much longer in the application, so that if they are lost through some means, then at least that they probably would have lost their functionality many, many years into use, rather than sort of literally be discarded relatively quickly after its initial use. But I don't know if you have some more to...
No, I think we've probably run out of time, I think.
Yeah? OK. It does look like we're out of time. Just one last quick thing for this audience, which a lot of people are involved in industry. Do you have any advice, any kind of good words of wisdom if they want to look into adding materials that put the planet first into their process? Any?
I would always insist on knowing what it is you're using.
Great. Any?
I just ask as many questions as you can. I think navigating sort of materials and sustainability, it can be really, really complex. But I think the more questions you ask about the origins and the processes, the better, and you'll know what decisions to make.
Sophie, anything? No?
Yeah. Make a product that people want and people need. Otherwise, what's the point? Use materials that you know green, and just make the best product, the most durable one.
Thank you all very much. Thanks.